We've just tripled the printing speed of flexible TPU on our Sovol Zero by bypassing the biggest hurdle in printing flexibles. As usual, success did not come immediately, so we are giving you a little insight into our design and prototyping process. So, the big reveal: today we installed that unidentified component we manufactured last week, a custom top feeder for our smallest printer, which solves the physics of the spool with a simple trick. And we proved the speed increase using OrcaSlicer's built-in calibration tool. And stick around until the end, because we are using this upgrade to print this mysterious flexible part. It's the little Zero's way of returning the favor to the giant SV08 MAX, a practical upgrade that might save your printer too, if your setup is anything like ours. I'm gerGO, and welcome back to gerGO Print 3D, where my young nephew and I are having a blast with our 3D printers and other fun devices. We enjoy all the enchanting things they enable us to make, but we are just as excited if the project is to improve these devices themselves. As always, this week's episode comes with curated, translation-ready subtitles, chapter markers, and audio tracks in dozens of languages. If you missed last week's video, we spent it turning our massive SV08 MAX into a safe fume-extracted ABS beast, just so we could manufacture these specific high-strength parts. And thank you so much for all the feedback we received on that video. Many of you recommended recirculated the scrubbed air to retain heat instead of venting it out. How could I have missed such an obvious idea? And others suggested adding mylar foil for better heat insulation. Makes so much sense. We also take warnings about the limits of active carbon filtering seriously. So our revised strategy is to use the MAX only when the parts are too big for our smaller, better ventilated printers. And in the future, we do plan to seal it even better, add that internal insulation, and maybe even roll it to the window to vent outside properly using wheels, like we did with our FLSON S1 Pro, do you remember? On the other hand, you might have noticed that despite having so many other brands of printers, we almost exclusively use our Sovols to print flexibles. Starting with our trusty SV06 Plus, which is still the king of flexibles in our workshop, thanks to the short, direct path from the spool to its strong planetary gear extruder. Not that we did not try the other bat slingers. Our Anycubic Cobra 3 is great, but feeding soft TPU through the Color Engine's meter-long tubes is asking for trouble. That was a definite no-go. And the Creality High? It looked promising with its single spool holder and short, unhindered filament path, but I was surprised to find no generic TPU profile in the slicer or on the device itself. The only option is high-speed TPU, which is barely flexible. That didn't stop me from trying softer filaments, which jammed the extruder right on cue. Let me tell you, taking that tool head apart to unclog it is a nightmare. It is clearly not designed for anything softer than 95A hardness. The Sovol Zero is not a bat slinger. However, it has that fantastic Sovol extruder that grips soft filament well. The only bottleneck was the friction in the long bottom tube, which limited us to a crawling 3.5 cubic millimeters per second in the stock Orca preset. The idea to bypass this tube actually started in a very recent video. Remember when we tried printing that silk TPU for the Hato glue gun stand? We rigged up this crazy contraption using our favorite Ulanzi camera stands to feed it from above. These extremely long selfie sticks that convert into camera stands are amazing finds on AliExpress. I can recommend them, but for this specific purpose, they were only practical as a proof of concept. Unstable and occupying our filming gear, but they confirmed the physics were sound. So we designed this dedicated top feeder. We printed the final version in ABS because PETG is not rigid enough, and PLA tends to creep or deform over time under the heavy load of a spool, whereas ABS keeps its shape and handles the heat better. But what if you don't have a massive enclosed printer like our Max to print engineering materials? Imagine if you could just drag and drop your 3D model into a website instead of a slicer. And instead of worrying about toxic fumes or fiddling with bed adhesion and warping, the part would just appear in your mailbox a few days later with great finish and made of the perfect material. That is exactly what our sponsor PCBWay offers. You don't need to own specialized printers to get high-strength parts. You can upload my design files, select ABS, nylon, aluminum, or even industrial-grade TPU, and let their factory do the work. It makes so much sense for one-off upgrades like this. Plus, if you check out the link at the top of the description, you help the channel and get a little discount on your first order. Getting to this final design took some trial and error. My first prototype in FreeCAD 1.1 was just these simple triangles printed on the FS on S1 Pro, but they felt way too flimsy and they were too big. They hit the panel screws. For version 2, I made the triangle narrower to fit between the screws and raised it slightly, adding a crossbar to improve stability. I also put extra thought into the horizontal connectors, adding stops to the top bar to keep the spool centered, and even accommodating a piece of PTFE tube to minimize friction, a trick Sovol uses on the original holder too. We printed all these pieces on the SV08 MAX in PLA first to test the fit. Finally, version 3 perfected the clearances and simplified that PTFE groove, making it ready for the final production print in ABS in last week's video. And now Levi is ready to put it all together.
I'm gonna put it together.
Let's see if he can do it.
Let's see what we are working with. Get the screws. I think we need 4 M4x10 and 2 M4x18. I believe that's 4. I got an A in maths, so...
You did? Really?
Yeah. These are the M4x18s. And let's start with the 18s. But first, let's get the Hoto.
Levi is a big fan of this Pixel electric screwdriver from Hoto. It's practical and stylish, and the pixelated display of the torque setting and battery level appeals to Minecraft players like him. Of course, beyond the look, it's perfect even for these hard to access screws here. Good news, if you want one, the code gerGO gets you a 15% discount and provides a little affiliate income for us. Right.
And
hopefully it's
that's stable.
Remove the top.
Carefully.
I usually put it here on the top of the laser.
Okay. And it's
see if it
supposed to fit.
G-Tech TPU. What are we making?
A little frisbee.
It's going to be a little frisbee.
Yeah, on the
A frisbee that fits the...
Whoa.
That's a very nice
Look
color.
at that.
Mm-hmm.
We have to get this and
Simply. That's why we have 4 hands, right?
and I put it up.
We just need to remove that little piece here that I usually lose. I lost it.
gerGO classic.
But it's not as bad as it looks. Except
No.
you can take... You always remember to press it down and then you can pull out this PTFE tube. And this is a much more direct way to the extruder than around here. We can send the print from the computer.
Okay.
Ready for victory. Victory, however, came a bit later. We started the print and went to play some VR. The next time we checked on the printer, we were very lucky to catch this ugly tangle in time. The print eventually succeeded, but it took a few more tests to spot the cause and fix this inevitable physical flaw. See, without the bottom tube to constrain it, the filament gets pulled sideways as the tool head moves through the edges of the bed. It eventually jumps off the spool and tangles around the axle. My first thought was to design these spool stops. to keep the roll centered. Way over-engineered in typical gerGO fashion, I printed them quickly on the Zero itself. They fit, but they didn't solve the problem. The angle was too steep and we were still getting tangles. The solution turned out to be much simpler and even more practical. We needed a guide. I realized we could relocate the filament runout sensor by moving it from the back of the machine to directly under the new spool position. It acts as a constraint guide, keeping the filament path straight regardless where the tool head moves. This was that last part we printed out of black ABS Plus at the end of last week's video. The Zero uses Sovol's upgraded runout sensor with internal idlers, so unlike older ones, it adds almost zero friction. We just had to extend the sensor wires to reach the new location. I'm actually using a spare here so I can revert to the original setup quicker when printing other materials, but you get the idea. We are publishing the STL files for this complete top feeder along with the bonus Max project we will reveal in the very end of this video on CALTS 3D. Links are in the description right below the like button. Thank you if you take a moment to click it, but only if you haven't already. A second click would be a total fail. What a silly dad joke, and I'm not even a dad. Anyway, with that tangle tamed, it was time for science. We ran the max volumetric speed test in Orca Slicer. To learn more about these calibration tests, we made a whole video about them. It might be worth a watch. The stock profile limits us to 3.5 cubic millimeters per second. With our new top feeder, you would not be able to guess it. We pushed it cleanly past 11. You knew that from the video title, right? Still, that is over triple the flow rate. To celebrate, we printed yet another TPU frisbee at the new high speed. Now we have a whole pile of them ready for some indoor frisbee golf. Watch our feed for updates on this. But this last one has no under extrusion. There are no tangles, and this perfect flexible toy printed in a fraction of the time. Whoa. This is great fun, but I promise you one more thing. Remember that squishy Max upgrade from the beginning? You know, we ended up placing our SV08 MAX directly on the floor of my living room, right behind the door. We are both extremely careful, are we really? But the danger is still there for the door to slam into the printer's frame. We used the Zero, now fully capable of high-speed TPU printing, to create this little bumper. We printed this at an unbelievable 143 millimeters per second speed in just over 2 hours, from regular, very soft and very affordable G-Tech TPU. I remember when we would have been happy to print PLA at this speed. The squishy bumper slides right under the Max's frame, providing a custom-fit flexible cushion, spelling out the name Max. It's the perfect example of our printers working together. The Max built the upgrade for the Zero, and the Zero built the protection for the Max. Such a satisfying circle of support. And speaking of support, we are extremely thankful to all of you supporting our work by liking, sharing, and commenting on our videos, downloading our models, and clicking on our affiliate links. I admit we might have a bit too many of these, but at least you don't have to ask for them. Some of you even go as far as giving us direct sustaining financial support on Ko-fi.com. Big thank you to our newest supporter, Jumapili, and our longtime friends, Tech Geek, Steven, Wink, Jan, Ole, Fat Papa, and all the others. None of these projects would be possible without your generous patronage. Please use this link if you want to join them, also in the description. If you haven't yet, be sure to watch the previous part about printing this top feeder here, and our detailed video on all the Orca calibration tests I mentioned earlier. With all these ready, we can go print 3D. Thank you for watching yet another gerGO Print 3D video all the way to its end. Let's stay flexible.